Okay, so hopefully while Miss Burke was changing from part one to part two, you were able to stop and summarize the information that you wrote down for food webs. So at the bottom of your paper, I want you to make sure that you're writing in complete sentences, that you're putting everything together, summarizing and synthesizing. Okay, so that means putting things together, your thoughts about the food web. So if you didn't do that, then have Miss Burke pause this right now, and then you can do that at this point. Okay, so now that you've synthesized that last bit of material, flip your page over and you're going to need to make another template. Remember, it doesn't have to be perfect. Just draw your line down and your line over. Okay, so the last piece that we need to talk about are energy pyramids. And I know from the pre-assessment, that was one area in which you guys were weak in, and you weren't sure about. So let's learn more about energy pyramids. So over to the left of the line, you need to write the keyword energy pyramid. Okay. And then to the right of the line, we're going to write that it's a diagram that shows the amount. I'm going to abbreviate amount with AMT period of energy that moves from one feeding level to another. Okay, so it's a diagram that shows the amount of energy that moves from one feeding level to another. Now this is in your book. It's on page 46, I believe. And this is what we're talking about when we talk about an energy pyramid. You see that they're organized within this pyramid by um, the feeding level. So first at the bottom you have the producers, then you have your first level consumers who are going to eat the producers. Then on top of that you have your second level consumers that'll eat the first level consumers. And then you have your third level consumer that's going to eat your second level consumer. So this is what we're talking about when we refer to an energy pyramid. Okay, so in this energy pyramid, most of the energy most of the energy is available on the producer level. So that's the bottom level. So you can say it's available on the producer or the bottom level of the pyramid. So you all know about the pyramids of Giza because of your structures project. There's so many kids that pick that structure. And you know what a pyramid looks like. I just showed you a picture of a flattened pyramid diagram, but you know that the base of that pyramid is going to be the largest part. So that's where most of the energy is going to be because that's going to be representative of the biggest part of the pyramid. And as you move up the pyramid, you also know that it's getting smaller. So as you move up, you're going to have less energy. So as you move up the pyramid, each level has less energy than the one below. Okay, so as you're moving up through these levels, you have this transfer of energy, and only about 10% of the energy is transferred. So only about 10% of the energy is transferred to the next level. Okay, 90% is used for life processes, so keeping that organism alive, or lost to the environment as heat. So as you were walking into school, it was probably cold enough that you could see your breath. Okay, you might not notice that you're emitting heat when you're in a classroom, but when you're outside, you can see how you're emitting that heat. And so you're losing energy because whenever you emit heat, that's part of that energy that's keeping you going, that life process that keeps you alive. And that's part of that 90% that you need to function. The 10% that you have left over is then passed to whatever would be eating that organism. And because, and I'm going to start a new page, which you might have enough room. Okay, so because that 90% is lost, I'm going to say at, so that's a little at symbol, at each step, then there's not enough energy to support a lot of feeding levels in an ecosystem. So there's not enough energy to support many feeding levels in an ecosystem. Okay, so let's take a look back at our energy pyramid. And you see at the energy pyramid, you have 1,000 kilocalories. You guys know about calories because it's on the back of cans of pop or food wrappers. You know that that's the energy that you need to function. So the producers have, let's say in this example, 1,000 kilocalories. 90% of that's going to be used to keep them alive, keep them functioning. And then 10% is going to be passed on to whatever eats the producer. So 10% of 1,000 kilocalories is 100 kilocalories. So these first level consumers who are most likely going to be an omnivore or an herbivore are only going to get 100 kilocalories from eating that producer. So 100 kilocalories they have to work with. 90% of that's going to be going to their life processes. And that 10% that's left over will be going to whatever eats these little rats or mice. So these prairie dogs, they're going to get 10% of those 100 kilocalories. So that gives them 10 because 10% of 100 is 10. So you have your prairie dogs as second level consumers. And they are going to have 90% of 10 kilocalories for their life processes. So that's not very much. So what do you think they're going to be doing? They're going to have to eat more and more of those little rats and mice to keep them going because they're not going to get that much energy from just one. So you see that from one of the rats or the mice that they eat, they're only going to get that 10 kilocalories. 90% is going to them to function, and the other 10 is going to whatever is going to eat the prairie dog, like this big old owl at the very top of your food chain. And so 10% of 10 is 1. So you only have 1 kilocalorie for every prairie dog that this owl's eating. So that owl's going to have to eat a lot of prairie dogs for it to be able to sustain itself. So that goes into the question, why are there not very many organisms that are at the top of the food chain? It probably goes back to, if you're thinking when we're talking about populations, about how you're not able to have a larger carrying capacity. Because if you have a bazillion owls and they're all going to need a lot of prairie dogs to eat to sustain themselves, then you're going to wipe out the entire prairie dog population or whatever population of animals that this organism eats. So if you think in the ocean, oh, the big predator at the top of the food chain would be a shark, and you have a lot of sharks, then and they need as much food as they need to be sustained, then you're not going to have very many fish left and your ecosystem is going to be destroyed. So you need to answer that type of question. Like, why are there so few organisms at the top of the energy pyramid? So over to the right or to the left of your line, you can say reason for fewer organisms at the top of the pyramid. For fewer organisms at top of pyramid. So you could say that because so much energy is lost bet- between levels that it limits the amount of consumers an ecosystem can support. Okay. And if you want to write and make a little energy pyramid in your notes, that'd probably be a really good idea. So as people are finishing up writing this part of the notes down and you're summarizing what we just wrote about the energy pyramid, then I would also look in your book on page 46 and copy down just a little mini pyramid, energy pyramid that shows the different levels and that transfer of energy between those levels. I would also label it with the top and the bottom of the pyramids, with the bottom being having the most energy and the top having the least amount of energy. So make sure that you are drawing that you understand the bottom has the most energy and that the very top is smaller, so it has the least amount of energy. So we're going to stop here. You can summarize, draw your energy pyramid, and I'll see you tomorrow.